Hello, let's take a look at section 6.2. They want us to draw the radial field f of xy, where we have negative x cubed in the I direction and negative y cubed in the j direction. What we can do is plot some points or vectors. We can consider some xy points, and then we'll output some values for the I and the j components of the vector. We can try some really simple points like 0, 0, which is going to give us a no vector, degenerate vector. We have the point 1, 0. That's going to give us a negative 1, 0. We have the point 1, 1, gives negative 1, negative 1. Let's try 0, 1. And this is going to give us a 0, comma, negative 1. Let's try to put a negative 1, 1. And this will give us a positive 1, negative 1. Let's try putting a negative 1, 0. This will give us a positive 1, 0. Let's try putting a negative 1, negative 1. This is going to give us a positive 1, positive 1. Let's try putting in a 0, comma, negative 1. This will give us a 0, comma, positive 1 vector. And let's try one more, positive 1, negative 1. This will give us a negative 1, positive 1. Okay. We can see how this might look like. And these points that we have, I specifically chose them because they're a nice collection of points that's around the origin and easy to deal with. And for each of these points, we have an associated vector. For example, for the point 1, comma, 0, we have the vector negative 1, comma, 0. So negative 1, comma, 0 is actually a vector from the origin that goes to negative 1, comma, 0. So that's our vector, but we remember we want to put this vector with a tail at the particular point. And so that's where that would go. At the point 1, 1, it's negative 1, negative 1. Again, we have the vector negative 1, negative 1, but we're going to move it so that its tail is at the point in question. And if we follow through the rest of them, we'll see that all those vectors will be going inward. And so if we pick another vector, maybe throw in another point here, 2, 2, we're going to get negative 2 cubed. So that's negative 8, negative 2 cubed, negative 8 again. So if we're over here, this is only 2, 2, but this goes all the way down to negative 8. And so your vectors would look a lot longer than this. And it looks like wherever you are, the farther you are, the longer those vectors will be. The closer you are, the shorter it will be, but it looks like it'll be always pointing towards the origin. Okay. Now to actually get a nice picture out of this, what we could do is we could take a look at the graph using a tool, a graphing tool, the CalcPlot 3D tool. Highly encouraged for this class. We can draw a vector field. Let's get rid of this default function and draw our vector field, negative x cubed, negative y cubed. And this is asking for a three-dimensional vector field, but we're only going to consider the two-dimensional vector field, and we'll make the p equal to 0. Now the number of vectors you want to show along the x and along the y, we should probably keep that about the same, and we're not going to do this in 3 dimensions, so we just need 1 along the z. In fact, if we restrict our view to 2 dimensions, then we're just going to be looking at our 2-dimensional graph. Okay, let's take a look at it. And it looks rather confusing. It looks like it's going inward, and so if you want to do less vectors to try to see what's going on, you can change these values and see less vectors. If you want to see more vectors, you can change these values again and see more vectors. If the length of the vector is not that important and you just want to figure out which way it's going, you can use the fixed length for all vectors option, and by clicking on that you get to see it a little bit neater, and it looks like it does flow towards the origin. Alright. Okay, so this is a way to use technology to view it, and a few of other problems will ask us to do that as well. All right, I hope that helps.